Let's continue the engine presentation with the exhaust after treatment. Exhaust after treatment is one of the biggest engineering challenges today. And there are many engineers out at different companies working with this. The after treatment system adds a lot of cost and complexity on the engines, but it's necessary by environmental regulations. There could be different rules and levels on the pollutions in different parts of the world. And there are also different types of pollutions and the solutions to deal with them for diesel engines and gasoline engines. There could be many different types of exhaust emissions. But for gasoline engines is the main interest on NOx, that is acidic, creates smog and have health effects. The carbon monoxide, that is poisonous, and the hydrocarbons, that is dangerous for both environment and human. In diesel engines, legislation mainly focus on particulates that create smog and health effects, and the NOxes, that is acidic, smog and health effects. This chart shows the legislation for off-road vehicles with diesel engines. On this axis you have the NOxes and the hydrocarbons in gram per kilowatt hours. On this axle you have the particulate matters, also in gram per kilowatt hours. So you could see that the emissions is normated to the engine power level. And here is the legislation limits for the Tier 1 engines. And the Tier 1 engines legislation come in about 1995. And you can see here that the Tier 2 show up, the Tier 3, Tier 4A, and this year it was the Tier 4B that get effective. And here you could see you only have a little fraction of what you have here in 1995. And of course, it has been a lot of engineering hours to make this come true. For gasoline engines, the three-way catalyst is the most common thing. It works perfectly on gasoline engines, but it needs stoichiometric mixture to work optimal. And you have three reactions inside one can. You have a reduction of NOxes into nitrogen, you have a reduction of carbon monoxide to carbon dioxide, and you have a combustion of the remaining hydrocarbons. So this is typically what you find on a gasoline passenger car. For diesel engines, there are several different technologies used. The most common one is the EGR, the exhaust gas recirculation, the DPF, the diesel particulate filter, the SCR, the selective catalyst reduction, and the NOx traps. The DPF, the particulated filter, is really a filter. Here you could see you have this honeycomb structure. Every second cell is closed. So you look here in magnification. Here the diesel exhaust stream goes in and it goes through this porous material and out in the next cell. And the soot is staying inside this one. The SCR is more like a chemical factory. You have urea, you have a dosing system, you have an injector that injects urea just after the normal oxycat. And there you get the SCR reaction where different kind of nitrous compounds is just becoming nitrogen. And it's very complicated to make this work at all power levels. It's complicated to make it work at winter climate because this one freezes. And it also is a cost of the system and the urea by itself. And the NOx trap, it works by you running the engine in a rich period and you add the NOx into the material. But then you run it in a rich period where NOx is becoming nitrogen and leave the material. This is not so common in heavy vehicles. It's more like in some passenger cars. The EGR is when you recirculate exhaust gases into the engine one more time. It could be an internal or external recirculation. You could cool it or not. And it reduces the NOxes by mixing in the inert exhaust gases into the combustion. So it slows down the process and lowering the combustion temperature. Now let's talk a little bit about trade-off curves. When you design diesel engines, every single engine design will have a trade-off curve between how much NOx does it produce and how much particulate. Because if you run the engine very lean, you have got no soot and no particulates, but you get very much NOxes. If you run the engine very rich, you get very little NOxes, but you get a huge amount of particulates. And out here, you see an old style diesel engine from the 70s or 80s or something, naturally aspirated, no turbocharger, no electronic control, no fancy at all. And then by introducing like turbocharging, you can push in the line. Turbocharging in intercooler even push it in further. And now you see, now you hit this exhaust emission legislation areas without any really exotic systems. You could use electronically controlled engines. You could push it even a little bit more. And here, by really advanced engine technology and other things, you could push it almost all the way in, but not really into the box. That's why you have to use different type of things to make it happen, to come there to almost zero. For example, if you start out here, you could go an EGR route down to here, and then you could use a DPF to come down there. Or you could do non-EGR and a DPF. If you are out here, you could use an SCR to end up here. But there's one really big drawback with this. You see here, if you want to tune your engine for optimum performance, it goes in this direction. And if you go out too far out here, it will consume a lot of urea to make it come back here. And that might make it not economical. Okay, that was all for today. Thank you very much.